Hey guys, today we're going to wrap up our unit on electrochemistry, and the week is going to look something like this. You're going to have today's lecture, which is not going to be that long, and then you're going to have a virtual lab to do today and tomorrow. Wednesday I'll post a wrap-up assignment, and that'll be your quiz for this unit. And then Thursday will be due. Friday, Monday we have technically no school because it is Memorial Day. And then we'll start our last unit the following Tuesday. Just a quick note on if you are doing missing assignments and turning them in late, please let me know, because I don't go back and check on things like Castle Learning or a Wiser worksheet unless you tell me to. If it's a Google form, I get a notification that you did it, but actually not always. So just let me know if you're doing missing assignments so I can make sure your grade is reflecting that. Okay, so let's get busy. So electrolysis occurs in an electrolytic cell. This converts electrical energy to chemical energy. So the voltaic cell we talked about last week is basically a battery. It takes chemicals and it makes electricity. This one is doing the opposite. So it takes electricity and makes a chemical reaction occur. This is something that's used in electroplating, which is how they make silverware, or how people make jewelry that is not, let's say it's not 24 karat gold, it's just a gold plating, so it's less expensive. Okay, so you should notice right away that this cell looks different for a couple reasons. It only has one beaker. There's not a salt bridge, and the electrodes are in the beaker together. So let's just label what we have. The first thing you have is a battery. So the other one at the top had a voltmeter to measure the voltage. This one has a battery to apply a charge. The positive electrode is called the anode. So in the other one, we didn't talk about the signs, but in a voltaic cell, the anodes are negative and the cathodes are positive. In this one, it's flip-flopped. You do not need to know that, but you'll see the reason why in a minute. And then in the bottom, you have electrolytes. And remember, electrolytes should be a soluble aqueous solution so that when it's dissolved in water, it can split into its ions and help conduct electricity. Okay, so let's talk about what happens at each part, and then we'll do an example. So at the anode, you still have oxidation, which is the loss of electrons. Charge goes up. Okay, at the cathode, you still have reduction, so that hasn't changed. You have the gain of electrons, and the charge goes down. Okay, so the other unique thing about this one is they tend to have, your anode tends to be a metal, whatever you want to do the plating, and the negative electrode is either inactive, something like platinum, or it could be a spoon, or anything you want to cover up with the metal. Okay, so we're going to pretend we want this electrode to be silver. So basically, when the battery gives a charge to the electrolytic cell, the electrode at the anode is going to get oxidized. So it's going to change from its metal form into the ion form. So Ag+. Okay, because oxidation is losing electrons. So the electrons are going to travel up through the wire again, still anode to cathode, so same direction. And then now what happens is that the positive ion of the silver is attracted to the negative cathode. So this one likes to kind of like travel over here. And when it travels over here, it touches this negative electrode and it gains electrons. As it gains electrons, it changes, it gets reduced and it changes back into silver metal. So basically this electrode gets covered with the silver metal so that the cathode gets bigger. So kind of the same, it's like the same idea, but a little bit different. Okay, so let's move on and we'll talk about that again. Okay. Okay, so electroplating is a type of electrolytic cell. So now you can see that instead of 2 electrodes, you have a spoon. It is used to prevent the corrosion of metals. It's also used to make things cheaper. The item being plated is always the cathode because you want the positive ions to attract to the negative cathode. These reactions require energy. They are never spontaneous. Okay, so I'll circle never, that's important. Okay, so once again, we have silver. This has to be the anode, right? Because electrons are flowing from the anode into the cathode. So this is the anode. What, honey? The cathode. No, Daddy went to drop off something to great grandma's house. He'll be back soon. Okay, so at the anode, oxidation occurs. So the silver metal changes into silver ions, okay, as the electrons move over here. So the silver ion, Ag+, is attracted to the negative cathode, and as it touches the negative cathode and gains electrons, it changes back into silver, and then the spoon gets covered with silver. Okay, so I think there's just a couple practice problems regarding electrolytic cells. So if you want to pause and try those, and then we'll be done with unit 16. Okay, what is missing from the diagram in this cell? A battery. All right, number 2, what is the purpose of the power source? The purpose of the power source is to convert electrical energy to chemical energy. Or you could say to start the reaction, something like that. Okay, this question, I'm pretty sure there's going to be one similar to this on your wrap-up, if I'm remembering correctly. Okay, explain in terms of Ag+ and Ag atoms. So when we say Ag atoms, we mean Ag0 metal. Why the mass of the silver electrode decreases over time. So the silver electrode is the anode. The nickel key is the cathode. So we're trying to plate the key with silver. So basically what's going to happen here is at the anode, remember silver metal changes to silver ions. And then at the cathode, the silver ion is attracted to the cathode, gains electrons. So electrons are flowing in here, gains electrons and plates this. So this one asks, why does the silver one get smaller? It gets smaller because Ag metal is oxidized to Ag plus ions. So the mass decreases. Okay, so that's it for the recording. I'll make another one to talk about your virtual lab. And that's it. Talk to you soon. Bye.